Hello and welcome to the hub2 API video. My name is Paul Reynolds and I'm a development lead at Wood. And this video is mostly aimed at technical users, but we hope it's also useful for anybody who just wants to learn a bit more about how our API works. The video is going to be in two parts. In the first part, we'll take an overview of the API and the kinds of applications that can work with it. Then in the second part, we're going to fire up an API client and see it in action. So, let's start by answering the question, what is an API? So API stands for Application Programming Interface, and all it means is that there's a way for two computer systems to communicate. So in hub2, it's a framework which we publish, which tells third-party developers how they can write software which can speak to ours using a common language that we both understand. So to use an analogy, it describes how to start the conversation, the kinds of things we can discuss, and also how we can be sure we're talking to the right person. The approach we've taken is to use REST, which stands for Representational State Transfer. This is a modern and widely used approach to building APIs, and it has some simple concepts behind it. So we pass data models between a client system and hub2 over HTTP using common internet ports, so there's no special firewall exceptions required. We want the API to be simple and easy for others to understand. We want the communication to be lean and efficient and to give us high performance. And we want the API to be scalable, to let us keep pace with demand as it grows. Most of the resources and data types within the API allow what are known as CRUD operations on them. So CRUD stands for create, read, update, and delete. And it's simply a set of methods which we can apply to any of the objects within our API, and you understand what you're going to get. So this allows the API to have a simple and a consistent interface. Resource URIs are well organized, and the HTTP methods used to speak to the interface are well organized and consistent using the CRUD methods. Lastly, and importantly, all traffic is carried over HTTPS connection to make sure we keep things secure in transit. Our API provides a blank canvas for other developers to create all kinds of software which can speak to hub2. One of the main reasons we chose to design the API using REST is that it doesn't predetermine the types of systems we can work with in the future. The possibilities are limitless, and we're excited to see the ideas for apps which will work with hub2 going forward. We like to categorize our API client into two main types based on the type of system it represents and the kinds of workflows it will have. We call them machine apps and user apps. Machine apps tend to be standalone automated systems. So for example, this might be software which runs on a customer's server, which updates hub2 with engineering data overnight, or it might be a reporting system which reads project data and merges it back into a database. These kinds of apps sign into the API as themselves, meaning that there's no place for somebody to be entering a username or a password. They're also written in such a way that they're able to keep their API key secret, since they're hosted on a machine which is private. They won't have a user interacting with the system day to day, since they tend to be automated. The hub2 API allows fine-grained control over the permissions assigned to apps. And for machine apps, these are assigned to the app itself. User apps are those which allow a user to sign in as themselves and are mostly aimed at mobile apps which are installed on devices such as tablets or phones. In mobile apps which are published and installed on remote devices, it can be hard to embed client secrets within the software and keep them secure. So this kind of app does not require secrets to sign in. In contrast to machine apps, user apps are designed to be used by human beings, and the client device may be shared by multiple users who each need to sign in as themselves. To allow this workflow, permissions in user apps are assigned based on the user signing in. So now that we know a bit more about APIs, let's look at how you can get started using the one in hub2. Requests made to the API need to include an access token, which lets us know who's making the call and what they're allowed to do. So the first thing you need to do is to register your app. To do this, you need to get in touch with our support team at gotechnology.support@woodplc.com. They'll talk you through the options available and get you set up with a client ID, which you'll use in your app to sign in. If you're building a machine app, you'll also be given a secret, which must be kept confidential. This is just like a password that you'd use for your account, and whoever has access to it can use it to sign in with your app's permissions. Now that we've got our app registered, it's time to look at some code that lets us authenticate or sign into the API. So I'm going to show you some code here which can be used by machine apps to sign in using the OpenID Connect client credentials flow. So this is the workflow that we use in hub2 to sign in for machine apps, which are signing in with a client ID and a client secret. Now, the good news is that most platforms and languages that you're going to be developing apps on are going to have a lot of this built in. So most platforms have got a library which will help you work with OpenID Connect. And there are a whole wide range of projects out there and examples that you'll find to support you in doing this. But what I'm showing you here is the longhand way of doing it, just so that you understand how the code works. So to get an access token that you can use against the API, first thing we need to do is make a post request to the token endpoint. So that post request needs to have some authentication. So what we need to do is add some headers to that request. So the first header we have is specifying the content type. And all that's saying is that the body of the request is going to be a form and it's going to be URL encoded. The next header is the one that actually signs us in and gets the token. So this is the authorization header. And we use HTTP basic authentication for this. To generate the HTTP basic token, all you need to do is take your user client ID and your secret and base 64 of them separated by a colon, and that will generate a token, as you can see here. So once you've got that, you need to fill in the body of the request, which is specifying two fields. One is called grant_type, and you need to set that to client_credentials. And what that's saying is it's saying to the token endpoint, I'm signing in using client credentials, and not any of the other grant types that we might specify in OpenID Connect. And then the other thing we need to specify is the scope. So what we're doing there is saying to the token endpoint, I would like a token that can be used for this particular type of API scope. And for hub2, we just have one simply called hub2_API. So this is what the request looks like once you generate it. So you're going to be sending to token endpoint. We see our headers there. You can see that the basic authentication is set up in the authorization header. You can see the body of request. We've got the grant type and scope set there. So we're all set to go. So we make the request to the token endpoint and it comes back with a response. So hopefully this is going to be a 200 response unless something's gone wrong. But you're going to get an access token, which is shown there. You're going to get an expiry on that token, and then it can tell you the token type as well. So we can see here that we've got an expiry of 3600 seconds. That means your token that you get from the endpoint is going to give you 1 hour of usage before you have to generate a new one. And then the other thing it tells you there is that the token you get should be used as a bearer token. So that means that anybody who holds this token is able to authenticate as you. If you're signing in as a user app, the workflow is a little different. So in that situation, the client itself isn't authenticating, it's the user itself that's authenticating. So it's a little bit more complicated, so I've not shown it here. But basically, you can look it up, and there's plenty of documentation online. We use the hybrid workflow of OpenID Connect. And to make life easier, we've also created a demo client app, which you can then use to see how it works, fill it in with your own client ID and test it out. So you can find that on our GitHub, which is shown on screen. Before we can go ahead and use our access token, there are a couple of other things we need to think about before we can make requests. The data in hub2 is organized into 5 layers of hierarchy so that it can be shared across organizations. And those levels are arranged in a tree structure with level A at the top and level E at the bottom, although in your case, they may be called something else, such as region, project, or scope. When users sign into hub2, they are asked to pick a level so that the software understands the areas of the data they want to work with. It's a bit like this with the API too. When clients make requests, the API needs to understand the context of that request so it can find the right data to carry it out. That's where the level header comes in, which lets the client scope the request to the right area of data. Each request to the API should include a header called GoTechnology level, which is set to the ID of the level at which the request should be targeted. To work out the correct ID to use, you can check the API wiki, which has guidance to help you choose, or you can contact GoTechnology support, who can also help you find it. Over time, the hub2 API will evolve as new resources are added or models change. To help insulate your app from those changes, a version header can be included with requests to tell the API which version of the interface you're expecting to work with. Where possible, no breaking changes will take place, which mean that versioned API calls will fail due to changes in the structure of the API. To set a version, add a header called GoTechnology API version with the latest version number. We recommend regularly upgrading this version during your test release cycle to keep up to date with new features of the API. If no version header is specified, the latest version of the API is used. So the next thing we're going to look at is how we can put all of this together and make some requests to the API. To do that, we're going to use a free package called Postman, which is really useful, and it's a good way of testing out the API without having to actually write any code. So you can download Postman from the URL shown on screen, which is getpostman.com. It's free and I highly recommend it. So this is what Postman looks like. There are several parts to the screen. On the left-hand side here, we can see basically a library of requests that I've set up just for the purposes of this demo. You're free to create your own ones when you start playing with the API. And then the right-hand side of the screen is kind of divided into two sections. In the top half, we've got everything we want to input to set up the request. So it could be obviously the HTTP method we want to use. We've got the URI that we want to send the request to. Then we can enter any headers or body parameters that we want to put into the request. When we click send, we'll see the results of that request appear underneath in the bottom section. So in that way we can sort of see the request and the response side by side. So it's really handy. So the first thing we're going to do is get an access token. So we talked about this previously, where we have to connect to the OpenID Connect ID server and ask for a token. Just for simplicity, I'm doing this all using the client credentials flow, which is what we talked about for our machine apps. So you can see here that I'm going to be making a request. It's going to be a post request. You can see all the other different kinds of HTTP methods here. So you might be familiar with get and post, but we're also going to be looking at patch, delete, and some others. So we make a post request to the ID server's token endpoint. So that's going to be /connect/token on the ID server. And some other parameters we're going to look at are the authorization. So we talked about using HTTP basic authentication. So what I've done is set up Postman to use that, and then I've entered the client ID and the client secret in the password using our password boxes here. Now Postman will set this up for you. It will automatically base64 encode this for you, and if you hit preview request, it'll even show it in the headers section of the request. So if I go and look here, it's automatically put in an authorization header using HTTP basic for me. So as I said, a lot of clients will do this simply for you without having to do it all. So content type header has been set as well for us. So that's, as we said, form URL encoded. And then if we look at the body, we should see the two parameters we talked about. So we've got grant type of client credentials, which means we're signing in using a client ID and client secret. And we've got scope, which we said would be hub2 _ API. So if I now send this request to the ID server, I'll get back an access token. So this is the response. It's in JSON format, so it's JavaScript object notation. So you can see the access token here has been sent, and as we talked about earlier, we've got an expiry and a token type as well. So I've set up Postman to automatically store this access token when we generate it. So we've done that in our tests. So all we've done here is set a local variable with the access token, and all that means is that later on when we're making requests to other endpoints, we don't need to copy and paste that token into those requests. It will just automatically put it in for us if we set the variable. So now we've got our access token, it's time to look at some other requests. So the first thing we're going to look at is how we can go about getting data. So one of the simplest things we can request is a discipline. So it's quite a simple object, it's just got name and description. So what I'm going to do is just show you some different ways we can get the data. So when we make GET requests using the HTTP method GET, this is the equivalent of the R in CRUD. So this is reading data back from the API. So there are two different sort of ways of getting data on GET requests in the API. One is to get a collection of the data, and then the other one is to get a specific record. So in this URI here, you can see that it just ends in the resource name. So it's /API/discipline. And if I make the request there, you'll see that I get back a whole collection of them in an array. So these are all the disciplines that I can access in this particular level. If I make a request using the name of a discipline at the end, I'm just going to get back an individual discipline. So you can see in that previous collection that we've got a discipline called E, electrical. If I put an E, a /E on the end of my discipline resource, I will just get one discipline back. So that's a good way of thinking about it, is having two different ways of getting data. You can either get a collection of the data, and you can do some other things in that, which we'll come to, such as paging and filtering, or you can just ask for one record. So if I go back to the collection, and look at this, we can see some different parameters that we passed in the request. So we talked about setting the authorization header. So we said we were going to use a bearer token, and that's what we've done. And I mentioned using the variable, the access token variable. So by passing this in through here in Postman, it just saves us typing it in each time, and we don't need to change it every time we request a new token. Another handy thing, as I said, is if you hit preview request, you'll actually see that token appear in the authorization header. So we can see here that we're setting three headers. The authorization one, which is giving us the access. We've also got an accept header, and we've set that to application/JSON. So all that's doing is saying to the API, saying I would like the results to come back to me in JSON. Now we basically only support JSON formatting at the moment. In future we may add other formats, but right now it's just JSON. And here is the GoTechnology level header as well. So again, I'm setting that from a variable, so you can see the variable here. So again, that's something that's quite useful to configure in a Postman variable, so you don't have to keep entering each time you make a new request. When you're working with collections in the API, it's going to return data in pages. So instead of returning all the records at once, it's going to return them in chunks of 20 items. If you want to increase this, or if you want to change the current page that you're receiving data for, you can pass some paging parameters to the API. We can look at some headers that come back in the request to get some more information about the kinds of pages that might be possible in this collection. So if you look at the headers that come back, you'll see one called xpagination and one called link. Now the xpagination header has got some JSON inside it, which gives you sort of metadata about paging for the collection. So we can see that in total, this collection contains 17 records. We can see that there's only one page because the default page size is 20. We can see we're on page 1, and we can see that we don't have a previous page or a next page. If we change these parameters, so if I go to another request which has got paging parameters, which are P for page number and PS for page size, If I make this request, you'll see that right enough I get 5 items back as requested, but you'll also see that the headers now contain 4 total pages. We can see our current page is 2, 5 items per page, and yes, we do have previous and next pages. Also, the link header now has links to the first, last, next, and previous pages. And this is going to be really handy if you're building an automated system that you want to just pull back all the pages, but you don't know up front how many pages there are, or if you're building a user interface where you want to give the user some links to the next and previous pages, but you don't want to generate those yourself, you can have the API do that for you in the headers. Some other parameters you can set on collections are to do with filtering. So what we can pass is a filter query string, which will select certain items out of the collection. So here I've added a query which says description contains L. So what this is going to do is just going to pull back disciplines which have an L in the description. So if I run that, there you go. We've got architectural, civil, drilling, all of these have L in the title. There's quite a lot of different ways you can filter. We have lots of different parameters that can be passed in these queries. In the API wiki, there's some more information about the kinds of things you can specify in query parameters. There's too much to go into here, but you can also generate these on screen in the user interface and then copy those same queries into the API, and you can get some quite advanced filtering going on. Another parameter you can pass into collections is sorting. So if I wanted to return all the disciplines sorted by name descending, I can pass a parameter saying O for order equals name semicolon D. So that will give me all the same disciplines, but this time they're ordered starting at Z and ending in A. And of course you can mix and match these parameters. So if you want to have disciplines containing L but sorted descending and page 4 of those, then you can certainly mix and match those and get the same result. So next we're going to look at creating data. So in our REST API, we create data using POST. So what we do is we make a POST request to the resource endpoint. So in this case, API discipline, because we're creating a discipline. And what we do is we pass a JSON model of the data we want to create. So as I mentioned, the discipline object is quite simple. It's just got name and description. So our model has just got 2 fields in JSON, once again, name and description. And we've just got some test values in here. So we'll send that to the API. And the response we get back is the same model we get back from the GET request. So we've got name and description. We've also got an ID, which has now been set by the server. And we get a status 201 created. So that means that the server has successfully created the discipline for us. It will also pass back in the header a location to the new resource. So this would basically be a get resource ID to go off and get the new discipline that we've just created. So that can be quite useful in situations where you don't want to generate that yourself in the client. You can just wait till the server tells you where it is and you can go off and select that item. To update a discipline, we have to use a slightly different technique. So what we use is what's called a patch document. So this time what we're needing to do is send a request to the API, but this time instead of sending it to the resource endpoint, we're making a patch request to the individual record. So we just created one called test space D earlier. And what we'd like to do is change the description of that. So if we look at the payload we're sending in the body, we have a document which contains some operations we'd like to do on the discipline. So this is detailed in a bit more detail in the wiki, but basically each of these records in this array are an operation that we want to do to the actual object that we're targeting. So here we can see we're wanting to replace the description with a new value, which we specify here. So if I run this patch, it'll go to the discipline and it will change the description to test discipline updated. For patch requests, the successful response is a 204 no content. That's just a sort of a REST standard, is that patch and delete don't actually return any content, they just return a success status. But we can prove that it's actually updated it if we make another GET request to test D. We'll see that now it's got the updated value, so it's worked. The last thing we're going to do to this discipline is get rid of it. So, not surprisingly, to do that, we use the delete HTTP method. And again, we're directing that towards a particular named record. So it could be /discipline/testd, which is what we created earlier. And we're just going to fire that off. And as I mentioned, we get 204 no content back. That's because there's nothing more to say than yes, we deleted it. So within the API, there are certain resources which can't be identified with just a single name. So a good example of that is secondary handover. So the number of a secondary handover is only unique within its parent primary handover. So to identify it uniquely in the API, we need two parts to the name. So let's look at an example of that. So in this resource we have /API/secondary handover, which is the collection we're looking at. And then we have a primary handover name. So it's AL069503C0001. Then we have a semicolon delimiter and then a secondary handover number. And what this means is that we can then uniquely identify that specific secondary handover, even though it's not unique within the level, because we're specifying both parts of the name. So if I make that request, we can get a look at the data. And here we can see the primary handover name, and the number is just 2. So it's unique within that primary handover. So there are a number of different resources within the API that have got this kind of characteristic. The best way to find those is if you look at our Swagger documentation, which I'll come to in the next section. They're clearly marked up in there, and it will tell you the order you need to specify those parameters if those are things that you need to work with. The last part of this video is talking about documentation. So this is how you can find out more about the API and how you can get some help. So one of the first places you're going to want to look at when you start working with the API is the wiki. So we have a wiki hosted on GitHub that is publicly accessible, that you can come in, you can find out information about how to register your app, authentication, setting levels, and then all about how to make different types of requests. So getting data, updating, creating, all that kind of thing. So there's lots of information in there to sort of sift through. That's a really good starting point. The other place you can look at is on the instance itself that you have access to. So we have our Swagger documentation. So the Swagger documentation covers all the different API endpoints that we host in our system, and it specifies the methods that you can carry out on those resources. It also specifies things like authentication requirements, headers that you need to pass, and it's a really good way for really digging deep into what you can actually do with the API. So if we just take the example we looked at before for disciplines, you can see all the different methods that we demoed earlier. So for example, reading a discipline, we can drill into this and find that we need to specify certain parameters. Here's the level and API version headers that we talked about. And we can see the kinds of responses that we're going to get back from this API endpoint under different circumstances. We can see this for all of them. There's actually quite a lot of different endpoints, so it can be a little overwhelming, but there's great information about all of them. If we look at, for example, the secondary handover one we talked about earlier, we can see that for getting the secondary handover, we need to specify both parts of the name. So this is an example where we talked about we need to specify the primary and secondary handover, and you can see the documentation covers that. So it tells us first we need the primary, and then we need the secondary. If we look at the post, we can see the sorts of data that we're going to need to pass in the model if we're creating a new secondary handover. And we can see the example model here, but we can also actually drill into the actual model and see things like maximum string lengths required. We can see which fields are required fields on this. So we can see that number, description, and primary handover, I've got an asterisk next to them, so it means they're required. So it's a really useful resource for working out how you're going to be able to send requests to particular endpoints, and if there's anything special you need to consider when you're working with those. So just to recap, the 3 places you can look to get help with the API are going to be the Swagger documentation, which you can get to on your instance at /Swagger. That's going to tell you all about the endpoints and methods available in your API. The API wiki, the address is shown there. That's a great place to start. It's going to give you some overall information about the API and the kinds of requests you can make. And finally, if those 2 places don't cover your question, you can always contact GoTechnology support at woodplc.com and they'll be able to help you out. That concludes the video. Thanks for watching.